Today I'm going to show you how to create an NFT minter. Hey, what's up guys? Daniel here, aka HashLips, and welcome back to a cool episode, series, extravaganza, whatever you want to call it. In the previous tutorial, we created a game, much like the one that you see here. This is called SafeLips. You can go to safelips.online on the Polygon chain to go and play our game that we've created. But this tutorial only showed how to create the smart contracts, how to set up the NFTs, how to mint the NFTs, but the data that's displayed here is rendered in real time. So the question is, how do we create a minter where we can make use of IPFS file storage and actually create the metadata that OpenSea and such marketplaces need in order to display your NFT properly? Well, that's something we're going to learn today step by step, and I'm very excited to do this once again with you guys. I want to say thank you so much for all the cool responses on YouTube. And check this out, guys. I started this only 21 days ago, and there's a bunch of stars on these repos that I've created. So if you get stuck in any of the tutorials, please go back to my previous tutorials because I cover more concepts as we go along. I want you guys to follow this journey from my first videos where we start programming on the blockchain to now, so that you guys can understand everything I do, and that's what I explain. So this video tutorial will be going much quicker. I won't explain all the concepts that I'm going to be using, but if you watch the previous tutorials where we create the art generator code, where we create the NFT game, they are all on YouTube. If you watch those tutorial series, you'll be fine. So let's get started, and thank you again. I really appreciate all your love and support. So go and like this video, go and subscribe if you're not yet, and if you really like the content, reach out and go and follow me somewhere and say hi. I always appreciate that. So like always, before we jump into the code, I always want to make sure you guys understand the concepts, the technologies that we are going to be working with. And today, the main concept is IPFS. It's a decentralized peer-to-peer file storage system where you can go and store something and actually recall it. And that data will stay there as long as one node hosts it at least. And there's millions of nodes, thousands of nodes. I don't know how many nodes there are, but IPFS is much more secure. Don't get me wrong, you can host your images of your NFTs on a normal web server. You can even host them on Google Drive if you want to. But that is not the preferred way for an NFT because the owner of that account can easily change it. And what is metadata when people talk about NFTs in the ERC 721 standard? So in order to understand that, we have to go to OpenSea's documentation. You can go anywhere and read up about it, but OpenSea explains it quite well. So how it basically works is, an NFT lives in a smart contract. This is an example of a smart contract. We will write our own smart contract in a higher version of Solidity because I want to use the latest technologies out there for you guys. But you create your smart contract and you'll see that there's usually a function base token URI or set token URI. And what you do basically there is you point it to a URL, which is something like that, right? And then that URL returns to us metadata. Now, the metadata object that it returns is JSON, and it looks like this. It's got a name and description, an image, and it also can have attributes and much more things. But we're just going to be focusing on these three fields in this tutorial. The other ones you can add by yourself. It's really easy after you understand the basic concept. But basically, that URL that we save on the blockchain represents this. And the reason why we don't save this directly on the blockchain, because it's too costly, right? We deal with gas fees. It's the blockchain. We can't save enormous amounts of data on it. So we have to save a link to this, and then here we get enough information to display. And this information is used by marketplaces, games, and everything that interacts with your NFT. So it's very simple and straightforward. Name goes here, the image goes there, the description goes in here on OpenSea. and that it all gets from the NFT's metadata. Metadata, like I mentioned, can be stored anywhere that has access to a server, and it can return it, but we are going to be storing it on IPFS. We will also be storing the image itself on IPFS. So we'll first have to create a link to store the image, then put it in there, and then actually wrap the JSON and make another call to the IPFS service so that we can store that. And that link will actually link to our NFT. It might sound complex now, but when I take you guys through step by step, it's going to be very easy to understand. I also just want to mention that we'll be using technologies such as Remix, Truffle, Ganache, and just to briefly explain what these things are, is they help you to write smart contracts, to deploy smart contracts, and also set up a stable development environment. These concepts have been explained in my previous tutorial where I create the NFT game, SafeLips.online, and you can go and check out those tutorials if you really want to understand in depth every single technology we are going to be working on today. For this tutorial, I am going to skip those explanations because I want to get to the IPFS part. But not only that, I want you guys to see this tutorial and implement it and be proud of it. So I don't want you guys to sit here for hours and do it. If you really want to get into the depth of everything I'm going to do, go and watch the previous tutorial. Otherwise, if you want to see how to create the NFT minter and upload an IPFS, stick with this one for now. All right, let's get going. And the first thing that we have to do is create our NFT smart contract. Okay, starting with smart contracts, it's very easy. Go to remix.ethereum.org. You don't need any development tools. This is an IDE in the browser. So let's get started. You can go to the workspaces and click on new. We're going to create a new workspace. And the next thing we want to do is, you can see there's some contracts and you can create a new contract over there. I'm just going to reuse this one. So I'm going to select ballot.sol and go and rename it. So we're going to rename this one to smart contract. Okay. And the reason for that is because later I want to copy it into the project folder, and that's what I've called that. So I will explain that just now. But let's double click on it, make sure it's selected, and let's remove everything in here. And we just want to leave the pragma solidity line as well as the license. So next thing we want to do is define the version of the compiler, and we're going to be using version 0.8, yeah, 0.8.0. Anything higher than 0.8.0 we want to use. And the reason for this is because I want to keep this relevant, and this is why we are doing this. It's easier to use a 0.7 because the ERC 721 contracts from OpenZeppelin, if you put in your dependencies, the previous version of this in 0.7 actually contains all the things we need for this tutorial. But I don't want to show you guys any of the old code, and it's not old, it's still relevant, it will still work. I just want to show you guys the newer way of doing it, and that's why I'm going to do this. By the way, they just removed it because sometimes people don't use it, and it saves on gas fees when you deploy your contract. Okay, so the next thing you want to do is define a contract. So you can write the word contract, and let's define the name. So we're going to say this is the smart contract, open our curly braces, and we want to inherit from our contracts that we imported from the top. So the two contracts that we really want to inherit from is the ERC 721, which is going to be our NFT, and the next one is the ownable. Okay, ownable. The ownable actually makes it then secure for us when it comes to minting and so forth. So you'll see that it moans and it says that we need to make this abstract, and the reason for that is because they want us to implement at least the constructor of the ERC 721. So that's exactly what we'll do. So just open up a space and let's write a constructor. A constructor function is a function that will only run once, and it will only run once when the smart contract is deployed. So keep that in mind. We want to actually give values to the underlying ERC 721 contract. So that's why we create a space. We don't put parameters, we can, but we're just going to define it right here in the smart contract. So what we're going to do is put 2 arguments in there, and I'm just going to call this smart contract, and then that should be it. Let's just see. Perfect. Now, if we deploy this contract, and I believe it will deploy, let's just see, what is it moaning about? It's saying wrong arguments count. Okay, we need another argument, and the last argument that it needs is a symbol. So it needs a name and a symbol. Perfect. You can see that our contract is ready to deploy, so we can deploy it and it will have all the functionality of an NFT and an ownerable. We will not be able to mint anything with this, so that's the next step we need to do. Obviously, you want to be able to mint your NFTs, otherwise the smart contract is useless. So let's go and create a minter function. So open up another space and let's call this function mint. So you start with the function keyword and you type in mint. And then what we want to pass in is an address, and the address we'll call recipient. And then apart from the recipient, we also want a string, which is going to be the URI. So we can write URI in there, but it won't work. We need to use memory before that, because for strings and structs and arrays, you need to use memory types, specification of storage. Next, we want to just define what is the scope, and this is going to be public, and it's going to return a uint 256. Perfect. So now this is our function, and it will return this uint 256. It doesn't have to return a uint 256. It really doesn't have to, so we can just maybe take this out just to avoid that error. But if you want to use that integer after you've created an NFT in your front, you can return that as well. So now we actually need a way of counting our NFTs that we mint. How many NFTs have we minted, and so on. And there is an easy way to track this. And the thing is, you can usually set up a uint and then just increment it, which is probably a very easy way to do it. But OpenZeppelin also gives you the counters library to use, and that's what we're going to be using, right? So how can we use it? We can first say, well, we are going to be using counters. So counters we're getting now from there. Okay, and we have to declare the for statement. So you say you're going to be using the counters for counters dot counter. Okay, and that just basically says you're going to be using this library as the counters, and you're doing the same with strings. And this is necessary because it's easier to use this for passing from integers, and it will not then break your code. But this is important so that it can work together very nicely. Next, we want to declare our counters, and we're going to say counter. Okay. This basically is where we define our counter, so we need to give it a variable name, and the variable name we can give it is a token IDs, and that's it. So now that we have this token IDs, which is making use of counters, as you can see, we are now going to actually increment it here at the bottom. So what we can do is define a uint 256 and then give it a name. So we're going to call it new ID. Okay, so we'll just call it new ID, and we're going to say, well, new ID is equal to the token IDs dot current. Okay, so what does this mean? Token ID dot current basically tells us that we want the current state of this token, of the token IDs, and that is what we're going to be using. So you'll see that token IDs also has another function, which is increment, which we'll just use just now. So, but for now, we're going to just say that and then end it over there. The next thing that we want to do is say, okay, so we want to then token IDs dot increment. Okay, so we want to increment it over there, and then in between this action, we actually want to mint the NFT. So in the underlying ERC 721 contract, there's a mint function, which is an internal function called mint, and it takes in two arguments, which is the recipient, the person who's going to receive the NFT, and the ID. And we have already defined the ID as new ID over there. So when we end this, this is basically going to mint us a token. So it's going to define an ID, which is maybe now going to be 0. And then it's going to say, well, give it to this address, ID 0, and then increment it for if someone wants to rerun this function again. And that's basically what's happening there. All right. So I think let's just maybe return this. So I'm going to say this does return a UN256, just so that we can here at the bottom return it. Okay, so we want to actually return the new ID, so that we know that once this kicks off, if we want to use it, we do have it. Okay, so the next thing that we need to do is actually find a way how we can make use of this URI. And we need to kind of say, this ID that we've just minted belongs to an image, a name, and a description, right? The metadata. So how do we do that? Well, first we need to define a variable that can hold the data. So what we'll define is a mapping. And a mapping in Solidity is basically a key value pair where you specify what type is the key, which is going to be uint. And we then say, well, the key values are going to be strings, because the strings are going to be the URLs that we attach here. And we need to give it a name. So we're going to call it token URIs. Okay, perfect. Token URIs. Now we're going to be using this token URI, but we first need to kind of make sure that we set it. So let's go and create a function for us. This is going to be an internal function. So start off with the function keyword. We're going to put an underscore, and here we're going to write set token URI. And set token URI will actually now allow us the contract itself to set it internally. That's why we append with an underscore. We define the scope as internal. So let's just go and define it as well here, and open our brackets like this. Next, what we want to do is we want to actually pass in something which would be a token ID. And let's think about it. We need two things. We need a token ID and we need the URI. So let's define a uint, and this is going to be token ID. And then we need a string, which is the memory, a memory string. And we're going to specify the token URI. Okay, this is the two things we need. And now how do we apply to our mapping? Very simple. We go and call our mapping's name, which is the token URIs, which is up there. And you open the brackets to specify where are we going to save this to. And because we're going to use the token ID, you put that there, and we're going to equal that value, that keys value, to the token URI. And that's how simple it is. So the next step is to actually call this function right here below mint. So we can put it in there. And the two arguments that we've just seen is the ID and the URI. But this time the URI comes from the outside minting function. So generally, just a heads up, you won't make things public when you do this. You would maybe make it public if you charge a fee for minting this NFT, but generally you won't go and do just leave it public. You'll make it maybe public, but only the owner can do this, and so forth, just to make it a bit more secure. For our purposes, we're going to leave it open because we want to be able to have anyone to mint, and that's the reason why we are leaving it open. But just for an example, so that you also know how to do that, you can say only owner here. And then once you've added this modifier, this will be able to only have the owner use this function. All right, so you can do it like this. But anyway, let's get on with our tutorial. Fine. So now, the next thing that we need is we've minted our NFT, and this will run. This will run perfectly. In fact, we can mint this and it will be good to go. The problem is OpenSea will not know how to read the data from our NFT. So we actually need to create a function for that. So let's define a function now, and let's call it token URI. Okay, so this function is going to be a public function, and we can make this public function a view because the person calling this is just going to view this. But the token URI is something sitting inside the ERC 721 contract under the storage, I believe. So we need to override this. So this is where you can say this is a virtual function, and not only is it virtual, and not only is it the virtual, but we also need to override it. Okay, this will make sure that we override the underlying function so that there's no conflict, and that the caller will get this function that we give it. Okay, we're going to define what does it return, and we can just simply return a string, which will be a type of memory. We can also give it a name, but it's not necessary. We know what we're going to return. It's just basically the URI. All right, perfect. So let's go ahead and return the URI so long. So we need to pass the function something. So the first thing that we're going to pass is a uint, and this is going to be the token ID. Okay, because we need to identify it somehow. Then let's just end this thing over there. It will break for now. Let's open it and let's go and return to the user. So first we're going to declare a variable. We need to use memory, and then we're going to go and say, well, we want to have the token URIs. Now this is this variable that you are querying, right? And you're saying that you want to get the value of this token. What is its URI? And that's how you do it, right? But you can't just do it like this. You need to assign it to a variable. So we need to put a equal sign there, and let's just define this as token URI. There's a lot of token URIs in here, so I just want to see so it doesn't conflict with anything. Perfect. It needs to be unique over there, and we're going to return it so that we get back our token URI from our mapping, and then we return it so that the user actually can use it outside of this smart contract. And that's basically it. To make it a little bit more secure, there is an underlying thing that you can do with token URI, and that is you can add a require statement in here, and the require statement can be exists. Okay, now exists takes in a token ID, which we conveniently have, and this require statement will just basically go into the ERC 721 underlying contract and basically check if this token already exists. If it does not exist, then it will break and it will execute out of this function. You don't want people to call this function on a token that's not really there, because it doesn't have any token URIs for it. Perfect. So I'm just quickly going to have a look. I see we do have a little bit of a bug. It says expected a semicolon but got a string. Where is that? Let's quickly have a look. It's probably there. And then we got another error which says identifier not found or not unique. Okay, so what does this mean? Let's just quickly see. Using string, do we even need this? Maybe it's strings, not string. Yeah, perfect. Okay, so that's strings, not string, and then there we go. Everything is working again, and we can deploy our smart contract. And now OpenSea will actually be able to read our tokens, and that's pretty cool. So the next thing that we just want to do quickly is find a way, because this smart contract will work. Everything is perfectly fine here, and we're ready to go and do our application. But the thing that people cannot do right now is map through our tokens and get back all the tokens for maybe the whole smart contract. Now, that is something that you can do in the front, but I don't mind showing you guys a way of doing it here in the smart contract yourself, so that you can use this and also have an easier way of extracting the token data. So the first thing that we want to do is we want to create a kind of a struct. Now a struct is a simple data structure which you can define multiple data structures inside. So let me explain. There's much more on the struct that I use in the game tutorial before this, but I'll show you a basic example. So let's call this struct something, right? Let's say we want to show the token in a way to the front where it's easier for the front end to render it. So let's just maybe call this render token. Very creative names in this tutorial, but you can call it render token, and then we can go and say, well, we need a uint256, which is going to be the ID of the token. And lastly, we're going to need not a struct, but a string, which is the URI. And that's a simple struct. But this render token will actually help us quite tremendously of getting all the data back at once in a big array. Because otherwise, you're going to have to map through a token and you don't know how many there are. You can also include the enumerable libraries, but I'm just going to show you a simple way of doing it right here. So what you can do is you can say function get maybe all tokens. Okay, so we're going to say get all tokens. This is not going to take any parameters. It's going to be a public view function, and it is going to return something. So we're going to say this will return our struct up here, which is going to be our render token, but it's going to return a list, and you just define the array symbol there at the end. We have to make this a type, so we'll give it memory. Okay, we're going to just return it like that. The next thing that we want to do is define an integer for a variable. Now this variable is going to be kind of the last token ID that was minted, and we know already how we can get that ID. We can get it from here, so we can basically just copy this whole line, but we don't want to make it new ID. This one we can maybe call latest ID. Okay, so latest ID will give us the latest current ID that we have in the smart contract, and then we can use it. We're also going to need a counter. So just to find a small counter in here, this counter we will be using in the loop that we're going to set up now. So that's why we need that. Next, we also need a array. So we're going to say that we need an array of render token, which will be the result. So we can just call it res, and then equals to a new render token. So the reason why you do this is because you need to define the array's length. Now the array's length is going to be easy. It is going to be the latest ID, right? Because if you think about it, we want a length of an array from 0 all the way up to the latest ID that was minted, so that we can populate this array. So the next thing that we're going to do is write the thing that I hate the most to write out. So we're gonna we're gonna create a for loop. So you can say, so I is equal to 0, blah blah blah, and then I. So as long as I is less than the latest ID. So just pause here for a second. This is going to start looping from 0 up until the latest ID, which is exactly what we want, right? And then the last thing is I++. Just to increment it, we're going to open our brackets, and then we have to do an if check. And the reason for this is so that our code doesn't go out of bounds. So we need to check, okay, cool, if this token exists that we're looking at, okay? Now, what do we define as our counter? We want to start this counter off at 0. So we're going to say, well, the counter is 0, and we're going to define a counter here, because we're basically saying if ID 0 exists, okay? If it exists, then we want to add it to our results. So we need to define a string, and we're going to call this memory as well. We need to extract a URI because if you see, our render token takes in a URI field and an ID field, and that's why we have to define it down here. Okay, so how do we get this? We can now say, well, token URI. Okay, we can actually call our function that we've created right here, and we can see that this function takes in an ID, and for the ID we can give counter because this is the current counter that we're working with. Well, when I say current counter, is this counter, right? So we're first going to get the URI, and then the next thing we want to take the res array, and we can basically push it in there if we want to, or we can just say, well, res counter, which will be the array's index, is going to be equal to a render token. And to instantiate the new render token, you don't have to use the new keyword. You can just say render token. It takes 2 arguments because it takes these 2. So it's going to take the ID, which is our counter, and the URI, which is the URI of our NFT. And then all you want to do is, after this if check, you want to increment the counter because now our loop is done, kind of. And then lastly, we want to return, right? So we're going to return the result. And there we have it. So we're done over there. I see I've missed another semicolon. So let's just run through the code and see where that is. You might encounter this a lot as well. And that is coding for you. So let's just see, line 38. Okay, so it wants one over there. Everything to me looks pretty fine. Okay, there. It needs equal sign. Perfect. And then lastly, it says data location must be storage, memory, or callback variable, but none was given. And this is on line 35. So there we go. Okay. I don't want to make this storage, so we're going to make this memory as well. Okay guys, so now we're at the point where we've written our smart contract, and this is the basis of any smart contract really. You can obviously go and extend this and make it more secure and all these extra things, but this is the basis that we only need for our purposes, right? And the next thing that I'm going to show you is a brief preview of what app we're actually going to be building, because this NFT contract can be used for anything. So this is a good practice to just practice and maybe use it for other projects. Just make sure you make it more secure. But apart from that, this is all you need. And the next part is going to be the IPFS part. So what I have here is the actual application that we'll be building. And if you click on connect, it connects to a Ganache CLI hosted blockchain on our local machine. It's not very UI friendly and looking very great, but that's not the purpose for this tutorial. The tutorial purpose is to show you how to embed IPFS, how to get metadata onto a smart contract, onto the blockchain, and have OpenSea show it. So basically this is the application. This blue thing over here is a canvas. And like I showed in my previous tutorials where you can render dynamic and generative art, you can combine this tutorial and the other one and create a beautiful NFT minter website. So I just drew something here, and I'm going to say mint up there. And what you'll see now happens is MetaMask pops up and we say yes. In behind the scenes, it calls our smart contract, it pushes the metadata, and it mints the NFT on the blockchain. This is now on the local blockchain, but once you deploy it, this will be on the real blockchain. And here you can see it actually shows the images. And how does it do that? So if we look in the console over here, if I just right click on the IPFS link that the IPFS has returned to us, which we actually upload to our smart contract, it looks like this. Okay, it's called a CID, I believe. Basically, it's an ID that points to the item on the IPFS network. And you can access this item through any gateway, and the gateway we are using is the Infura one. So there's different ways of saving this. But anyway, needless to say, here is our metadata. The the name, description, and image. And you can extend, like I said, with attributes, but this is the basic thing we need. So whenever OpenSea goes and queries for an NFT on our contract, they will actually get this. And then they will go and say, cool, display the name, the description, and the image. So if we click on the image, this is actually the image that we've created just now. So I hope this excited you guys even more to complete this tutorial right now. So up until this point, if you've enjoyed this, please hit that like button, subscribe, and I'll see you in the next video. Thank you so much and have an amazing day.